We're in section 11.2, hypothesis tests for the difference between two means paired samples. Here we're looking at hypothesis tests for two sample paired data. And remember that we use the statistic d bar, which is the difference between our sample means. Now, the way we perform the hypothesis test is very similar to the way that we do it previously. We state the null hypothesis, and then H1, the alternate hypothesis, and that's the same as it always is, right? Mu1 minus mu2 equals 0, or it doesn't, or it's less than, or it's greater than 0, right? So we're going to let D equal x1 minus x2. We're going to let D bar equal x1 bar minus x2 bar. And then we're going to let the standard error equal the standard deviation of the difference divided by root n. Okay? So then what we're getting here is that we are finding the test statistic T, or they call it T alpha over 2. And this is going to be T equals D bar minus mu1 minus mu2, which is usually 0, and then divided by the standard error. And this is going to equal D bar divided by standard deviation over root n. Then we're going to find the p-value corresponding to our t-score with, and then this is just going to be n minus 1 degrees of freedom. Right? And then you know the deal from here. P is less than or equal to alpha, then reject the null hypothesis. Otherwise, fail to reject. And state your conclusion. And again, note that this is simply a hypothesis test on the parameter mu1 minus mu2 using the test statistic d bar equals sample mean 1 minus sample mean 2. Okay. So let's consider a couple of examples. If we go into Excel, we can actually go to paired T over here. Right, and I think we can just go ahead and enter this in. Right, and we have 19, 15, 16, 23, 24. And then over here, we have 18, 19, 10, 14, and 17. Okay? So we compute the differences. They're right here, etc. Compute the test statistic, and then these various things right here, okay? Whoop. There we go. So what are the differences? Well, again, that's just this right here. Let's see if we can we squeeze it all? No, I don't think we can. The differences, we'll just say, are 1, -4, 6, 9, and 7. Now, the test statistic, right, is right over here. T, now we know it equals 1.402. How are we getting that? Well, it's going to be the mean of the differences. Do they give us the mean of the difference? I guess they don't quite do that. But anyway, we know it's going to be, let's see, 1 minus 4 is -3, 3, 12, 19 divided by 5. So it should be 19/5 minus 0 all over the standard deviation of the differences. Do they give that to us? They give us the standard error. 2.3537. And it turns out that works out to be 1.402. Again, really, we would just use Excel to get our answer. All right. And so if our hypothesized difference is going to be 0, right here, this is going to be 0. Then we see our p-value if we're looking at, what is this, alternate hypothesis is greater than, yeah, it looks like we can't reject it, right? No, because P equals 0.0909 is greater than alpha equals 0.05. And a similar thing happens here. Okay. So that's what we're doing right there. Right. And as always, we're using Excel. Right, we've got this situation. You can pause and read the question. But again, we have paired data. So let's go ahead and enter it into Excel. Right, so we have paired data. We are hypothesizing the difference to be 0. Right, and so let's just state our hypotheses really quickly. The null hypothesis is that mean pain level with drug A minus mean pain level with drug B equals 0. The alternate hypothesis is that, so if the mean pain level is less with drug B, then we would want mu2 to be less than mu1, which is the same as saying mu1 minus mu2 is is greater than 0, right? Be careful with the way that they word these things. Okay? So now we compute the test statistic. Well, Excel did that for us. 1.393. Again, just showing this is what I got. So we're just going to say that T equals 1.3693, excuse me. And state a conclusion. Well, no. We're not getting it, right? Since P equals 0.11 is greater than alpha, which equals 0.05, fail to reject the null hypothesis. And conclude there's not enough evidence that, I guess I'll say, drug A pain, or I guess I'll say that drug B pain is less than drug A pain. There you go. All right, now as always, we need to assume a couple of things when we're doing this stuff. The sample of matched pairs is, of course, random. The sample is large, which means n is greater than 30, or the population, or the difference between the pairs is normally distributed. All right, and just one more super quick thing. We don't even need Excel for this guy. Just look at this display. Again, I usually don't test this kind of thing, but you could see it on a common final exam. Is this a left-tailed, right-tailed, or two-tailed test? Well, given that we see this, it's going to be a right-tailed test. How many degrees of freedom are there? Well, if n equals 18, okay. What is the p-value? Well, I don't think you can just see the p-value, right? And last but not least, can we reject H naught at the 0.05 significance level? No. Failed to reject the null hypothesis because P equals 0.17 is greater than 0.05, which equals alpha. Now we're done.